Hello, my name is Scott Miller and I'm the instructor for this course. The purpose of the video is to go over proper graphing techniques. My experience with this course is that students either don't know how to create a graph properly or choose not to. Either way, it negatively affects their grades on lab reports, the sole items for determining a grade in this course. Now, I can't help those who are choosing not to do a graph or graphs correctly on a lab report, but I hope to offer some help to those who want to do them correctly so that it will positively affect their overall grade in this course. To begin, we need some data. The first step is to load the data. Make sure that the data to appear on the horizontal axis is in the first column. Highlight both columns. Under Insert, click on the scatter plot in the charts icon and choose a scatter plot with no lines. Now grab your corners and make your graph a bit bigger. Remember that you're going to want to cut and paste this graph into your lab report. So if you make it big enough, you won't have to try and manipulate it there. Now you can see we've got some extra space here, and we'd like to make our graph cover the entire piece of graph paper. So we can do that by doing the following. Click on the plus sign and click on Axis Titles. And if we go to Axis Titles, what that will allow you to do is to choose each axis title and give it an appropriate title. Now in this case, we're plotting time on the horizontal axis and distance on the vertical axis. So if we type those in, deleting what's already in there and putting in something much more appropriate. We can even go and put in an appropriate title for our graph, which in this case is going to be distance versus time. Now if we go back to the plus sign, we can further change our graph by choosing each range on each axis, and under Axes and More Options, you get a gray box that has data boxes in it. We can change the number of the maximum and minimum under bounds to better spread our data. In this case, we know our largest data set is roughly around 25, so we could, for example, change this to 26. Do be aware of the fact that sometimes when you make that change, the minimum will change as well, and if we want to force it to be, in this case, 0, we literally have to type that in. Now the rest of this we could pretty much leave alone. We can now go over to the vertical column and do the same thing. You'll see that in the gray box a different set of bound values appear. It looks like 6 is the largest number on our graph, so we can change 6 for the maximum. 0 does stay put in this case. If we run the graph up and down, we can clearly see that 0, 0 is down at the origin in this case, and not all graphs will be that way, but it is in this case, and that we have a nice display. We can even go up to chart styles and choose a chart style that is more appealing. For example, this one actually puts in small grid blocks so that the chart looks a little bit more like graph paper. Don't worry about the symbols. They're basically are the error bars on this data. So if we close the gray box for a minute and choose something outside of the chart itself, we have the beginnings. Of course, what we'd like to do is to fit this data to some sort of line. So we click in the chart area itself, go to the plus sign, and down here at the bottom you'll see trend lines. Now don't choose the trend line, just go over and select more options. And you'll be given several options. You'll see that linear is the default, but that obviously is not the shape of this particular graph. In fact, if we click on polynomial to order 2, we clearly see that we have a line that passes through the data. Some of it is above, some is below, but remember this is a trend line. So therefore it just has to show us the general trend of the data. It doesn't have to connect to every point. It's an averaging tool. We can even go down below and click on display the equation and move it so it's not right on top of the graph. We can actually move it. And if we look carefully, we see that we have an equation that has an x squared term in it, an x term in it, and a constant term. If we go to our textbook and look up our kinematic equations, we would discover that one of our kinematic equations does have a squared term in it and a single power term in it. That happens to be if time is the values here, and that is in fact what's on our horizontal axis. So the x's here could be replaced with t's to make it more in keeping with our equation, and we would have created a line that is basically one of the kinematic equations from our data. Now, as was pointed out in the video on how to do this by hand, it was actually more useful to have a linear graph as opposed to one that's a part of a parabola. So after we cut and paste this particular, and just click on it and right click should allow you to cut, and then you paste it into the bottom area of your lab report underneath the questions. We're ready to create a second column, our second graph that would be a distance versus time squared. So I'm going to click outside the box here. I'm actually going to delete this graph because the assumption is I've already copied and pasted it. And then I'm going to go up to the B column, choose it, right click, and scroll down to where it says insert. And here is where I'd want to put my time squared data. Now I can label this column time, put a 2 there, and then a space with seconds with a 2 following it. And if I do return, that sets it up. I can click on the side here and open that up a little bit. Now I can actually go back up to this column, or up to this cell, and if I go and highlight each of these 2's, I can use the font menu to write them as superscripts. And of course, since they're supposed to be squared, then that's how we would do it. Now it doesn't seem to change anything in the white space here, but you can see down in the chart, down in the Excel region itself, it clearly is making each of those squared. Now obviously we've got something like 51 data points, and we don't want to have to square each by hand, but we can take care of that using Excel as well. We can use a feature called formula, and we introduce a formula by first typing an equal sign and then following the equal sign by what we'd like to do. In this particular case, we'd like to take whatever's in A2 and multiply it by itself. That's how we would square that number. So we type in a capital A2, hit the little star key, which in this case is a shift 8, and then another A2, and that's A2 squared. Well, 0 squared is 0, so that doesn't surprise us. Now what we want to do is grab this little corner down here and pull on it until we have reached the bottom of the time column. And if we do that, lo and behold, every single one of those time values is now squared. At this point, we're ready to do exactly the same thing that we did before. We can choose our B column and our C column, because we still want the time squared to be on the horizontal axis and distance will be on the vertical. We go to Insert. We once again choose our graph and make sure we choose the unconnected scatter plot. We can make it a little bit bigger to accommodate our eventual cut and paste into our lab report. And again, we may need to adjust the size even in the lab report once we get it inserted, but we want to make it big. You'll notice that it is pretty linear, but it's not exactly perfect. And of course, data is never exactly perfect. We can, as we did before, choose the plus sign and look at, for example, we want to put axis titles in, so we can go and, as we did before, type in the appropriate titles. This time, of course, the vertical axis is still distance and meters. The horizontal is now time squared and second squared, just like the top of the column is. And of course, we could also change the label for our graph of distance versus time squared. I'm just going to move through this very quickly. I'm not going to adjust any of the things we did before, but I am going to go down to trend line, and again I'm going to choose more options. And the reason is that I want to make sure this actually does make sense. Now notice if we scroll up and down, our line doesn't quite fit the data. Some of the data is above and below the line that is best fit to this. But again, this is an averaging tool. The trend line is not supposed to be connected dots. Some of our data will be above, some will be below. So we can choose linear because it is the best fit. You can experiment with the others if you want, but I believe you'll see that linear is a good fit. And again, we can come down here to the equation checkbox, click on it, move it a little bit away from the data if we want to, if it happens to be put right on top of the data. And there again is our equation for our line. Now remember, if we were to convert this into one of our kinematic equations, we'd have to, in this case, replace the x's with t squared, because that's what's plotted on the horizontal axis. But if we compare this newly created equation to one of our kinematic equations, we would clearly see that the slope, which in this case is 0.0098, is supposed to represent half of the acceleration. So we can very quickly extract the acceleration from the slope of this particular line, and in this case there is no t value, and that makes sense because we did not expect to have the robot moving ahead of time. It started from rest, so that at time t equals 0 there is no initial velocity. So the initial velocity is 0, so that term goes away. And of course it implies from the equation that there was an initial starting position away from 0. That probably comes from the fit of the data, which we sort of expect because data is not perfect. So we're going to get a little bit of deviation. So that is pretty much in the error bars, if you will, if anything else. So in conclusion, we have seen how a graph can be used to show how two variables can be related to each other. But to clearly see the relationships, the graphs must be done properly. We will be using graphs in many of our lab reports to verify some of the relationships that are covered in the corresponding physics course related to this lab course. Feel free to refer to our textbook to see how those relationships are and how they relate to the labs that we do in this course.